All right, so in this video, we are going to solve these exponential equations over here, and we're going to do these without a calculator. These are a bit difficult, but they're pretty much the hardest types of questions you can get without a calculator. So let's get into them. For this first one here, I know that my common base for these three terms is going to be 7. I'm going to change everything to a 7. 49 is 7 squared. 7 will just stay as 7 because the exponent is 1. And a square root of 7, if I convert that to exponent form, is just 7 to the power of 1 over 2 or half. Next thing I'm going to do is combine these two like terms. When two terms are multiplying, you add the exponents. You can also expand the bracket there and turn that into 2x minus 2. So 1 plus half is just 3 over 2. Now that I have one base on both sides and they're the same, I can cancel them off. So I have 2x minus 2 equals to 3 over 2. I'm going to add the 2 on the other side. So 2x equals 3 over 2 plus 2. You want to give this a common denominator, so multiply by 2 on the top and the bottom. So 2x equals 3 over 2 plus 4 over 2. 2x equals 7 over 2. And last step is we're going to cross multiply the 2 over into the denominator, which gives us x equals 7 over 4. Let's take a look at the second question. Now it's a bit hard to notice, but the common base in this second question is actually going to be 2. First thing we want to do is convert this into a fraction to make our life a bit easier. I know you don't want to hear that, but fractions are easier than decimals. 0.25 is just 1 over 4. Then you want to convert the 4 into a 2 squared. And then we want to move the 2 squared to the top, so we'll make our exponent negative. Comes negative 2. Now the bases are the same, just cancel them off and solve the equation. So 3x minus 4 equals negative 2. Move the negative 4 and add it on the other side. So negative 2 plus 4 is positive 2. And finally, just divide by 3. So x equals 2 over 3. Third question here, common base between 4 and 8 is again 2. So I'm going to flip both of these to 2's. So I have 1 over 2 squared, power of x plus 4 equals to square root of 2 cubed. And I'm going to move this to the top. So I have 2 to the negative 2 times x plus 4 equals, and I'll get rid of the square root. That's just going to be a denominator of 2 in my exponent because square roots turn into fractions. Then we can just rewrite this in a slightly easier way. We can move the exponent outside and write it like this. Now the bases are the same, so they can cancel off, and we can just solve this. First thing here I'll do is I'll cross multiply that negative 2 to the bottom. So x plus 4 is going to become negative 3 over 4. Then just x equals negative 3 over 4 minus 4. Make a common denominator here, so multiply the top and bottom by 4. X equals negative 3 over 4 minus 16 over 4, which means that our final solution is just x equals negative 19 divided by 4. Fourth question here. These numbers are pretty tough, but if I look at these two numbers, it's most probable that my common base is 6. I know 6 squared is 36, but what number would give me 1296? Well, if you were to do it manually and try 6 times 6 times 6, you'd pretty much end up with that solution at a certain point. But the way that I'm going to do it is I know 6 squared is 36. 36 times 6 will give me some like 216 or something like that. And then 216 times 6, I can tell will give me 1296. So I can do this one mentally, but if you cannot do it on paper, what you also notice is 1296 will turn into 6 to the power of 4 And we also know 6 to the power 4 is the exact same as 36 squared. And if this is 36 squared, the square root of 1296 is just 36. So there's a lot of ways to do this problem. And the best common base here is to actually just do the square root of this, which is 36. But it's a bit hard to do that without a calculator. You have to be really good at mental math. But in the end, it's going to turn out like this because square root of 1296 is just this. Now our bases are the same. We can cancel this off. We can solve for the exponents. 2x plus 4 equals to x. Subtract the 2x on that side. So 4 equals to negative x, which means that negative 4 equals to x. All right, fifth one here, we're having stuff added in this one. So you want to get rid of this number first and subtract it on that side. So 2 to the power of 2x plus 2 equals 64. 2 to the power of 2x plus 2 equals 2 to the power of 6. Cancel out the bases. 2x plus 2 equals to 6. And just solve this. Subtract 2. So 2x equals to 4. Divide by 2, which means x equals 2. Last question here, 9, 81, 27. My common base is going to be 3. I know 3 squared is 9. I know 3 to the power of 4 is 81. And I know 3 cubed is 27. There's a bit of a typo there, but that's 27 to the power of x. The 3 cubed is my replacement for 27 to the power of x. Just going to multiply this 2 into the exponent here. So this becomes 4x plus 2. And on this side, I'll multiply these two terms, which means I add the exponents. I have 4 plus 3x. Common base on both sides. I can cancel. Now I can solve for my exponent. Subtract 3x on this side. So this is x. And I'll subtract 2 on this side. So I just get x equals to 2 as my final solution.